quick moment to talk about higher order derivatives. So far, all we've done in our derivative experience is take the first derivative of a function. Remember, the derivative is the slope of the tangent to the curve at a point along the way. Hey, that's our song. But ultimately, the derivative was the same thing as the rate of change. The derivative is the rate at which a function is changing. And that's the idea behind calculus, is we're studying how functions change. Okay, now sometimes when you take the derivative of a function, you get another function, and that function is differentiable itself. So you can take the derivative of the derivative, okay? That would be known as the second derivative. And you can take the derivative of the second derivative potentially, which would be the third derivative, or the fourth derivative. You can take many orders of the derivative. And that's something that comes into play in the second semester of calculus at the collegiate level. It's part of the BC calculus course. But as far as the AB course is concerned, we're only really concerned with the first two derivatives. So the first derivative and the second derivative. And again, the idea is that we are taking the derivative of the derivative. So if the derivative of a function tells us how the function is changing, then the second derivative of a function tells us how the change is changing, which gets kind of weird. But let's put it this way, and we'll talk about this more in a preceding video. You have a position function, okay? A function that tells you the position of where you are in front of this video, in your room, something like that. Now, if you move, then you now have velocity and you are changing your position. Now, the way you move can also change. You can walk very slowly while you're moving. You can walk very fast. And if you change from walking slowly to walking fastly, your position changed the whole time, but your velocity also changed as well. It went from slow to fast. That's known as the acceleration, and that is the change of the change. So that's where this is all going, okay? But when we're talking about the second derivative, I do want to talk quickly about the notation for the second derivative. So if we think about it, if we have a function f, okay, we know that the first derivative will be f prime with one tick mark after the f. All right, if we want the second derivative, well, then we're just going to add a tick mark, and we have f double prime, okay, with the second derivative of f. So the function, the derivative of the function, the second derivative of the function, or f prime, f double prime. And it doesn't matter whether we use f or g or h, okay, we would have g, which is g prime, or g double prime. All right, sometimes we think of a function in terms of y equals x squared, okay? Well, then we would have y and y prime and y double prime. That's another way to do the notation. The last notation is the Leibniz notation, which if you recall, when we had y, we could also write the derivative as dy dx, okay? And if we take the derivative of dy dx, where's my other marker? Hold on a second. All right, if we take the derivative of dy dx, well, now we have two d's in the numerator, and we have two dx's in the denominator. So our second derivative notation would be this right here. And that's pronounced d2y dx2. All right, it's another way of saying the second derivative. So if your first derivative is dy dx, like so, then the second derivative would be d2y dx2. So these right here are all notations for the second derivative, and we'll do a couple of examples with those in the next couple videos.